Hello, everybody. Welcome back to Planet X News. This is Scott from the Nibiru channel, and it is July 28th, 2017. And this morning, we are here with our physicist, and we are also here with Prep Aussie from Australia. Folks, how you doing?
G'day.
Oh, I'm very well. Thank you, Scott.
All right, you guys are.
And how are you?
Making sure you guys are awake here because
Yes.
we have a pretty good live stream here, ladies and gentlemen. We're going to be sharing more photographs and more information. Prep has got some great photographs and great information to show us, and we are going to continue to try and identify what this massive object was that was seen in this CME burst the other day. Now, I'm not sure if a lot of you know, but we had another CME at approximately, well, anywhere between 5 and 5:30 a.m. UTC time today. I did do a live stream on that first thing this morning whenever I woke up, and bingo, there it was. And this, once again, is coming from that very large sunspot, AR 2665. And as I mentioned earlier this morning, this was the sunspot that all of the big time professional scientists and all of the other folks on YouTube that said there is nothing wrong, there's no action, blah, 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 blah. Because that's all I heard was blah, blah, blah. Mm-hmm. But in fact, now this sunspot has produced several massive CMEs. And one of them just happened to light up what seems to be a massive object near our sun. Now, as I mentioned earlier this morning, thinking outside of the box, and that's what we have to do. Because none of us, even today's science, we don't have the evidence. I don't care what anybody says. I don't care what mathematical problem you place up on a chalkboard. There's no human being on the face of this planet that has ever seen this type of an event where another massive object gets close to our sun or within our inner solar system. All of the computer models state that the planets would be destroyed. The planets would be expelled from the solar system. A lot of these theories are based on gravity and so on and so forth. But we have to think outside of the box because science doesn't know everything. Taking into consideration that we're all human beings, still learning about the vastness of our galaxy and our universe. And who is to say that as we travel along in our galaxy, which travels along in our universe, what's to say that we don't encounter other stellar objects, other remnants of this universe and our galaxy? So there's no scientist alive that can say that's not possible. Ladies and gentlemen, everything is possible when dealing with the vastness of our galaxy and our universe. So thinking outside of the box, thinking with an open mind, I think that's what we need to do. You know, the photographs that came out of the CME the other day were pretty extraordinary, unbelievable, almost undeniable. Now, I've taken some of the photographs, a few frames going forward, and I spent all day yesterday, hours and hours, putting these photographs through different programs to try to enhance them. And Prep does a great job with his work in trying to show you these enhancements because this is what needs to be done. You have to enhance these photographs. You have to try and find what is being hidden. He does a great job of it. I've learned quite a bit from him in a short amount of time. But the photograph that I took yesterday moving I think 3 or 4 frames with the Soho image from the C2, that large object is moving. Now, when you're watching the C2 coronagraph, you have to remember something, that's coming in a time increments, 12 minutes or 16 minutes, whatever they want us to see. But the fact of the matter is, folks, you're not seeing straight through that object, because a lot of people made a lot of comments stating that, oh, I could see right through it. Well, I proved to you beyond a shadow of a doubt this morning that you could not see through it, and that the star-like objects are not stars. They are spherical, solid objects. Now, what exactly those objects are, we're trying to figure that out. That's what we're here for. And those photographs were pretty amazing. Now, Prep hasn't seen these photographs yet, but he has some good information to share with us this morning. And it's actually his evening down there in Australia. But what I'm going to do right off the bat,
late evening,
is I'm going to show you exactly what I'm talking about. Just give me a minute and I'll pull up the GIMP file. Now, this is one of the first images, and again, this is different from the images I showed the other day. This is several frames in advancement.
Scott, can you do us a favor? Can you go back to the original, the very original CME picture that you had, the red one?
Oh yeah, sure. You mean the original photograph? Let me see. I think it is this one. Yep. This has nothing has been done to this photograph. This is the actual CME that was produced on the 23rd, 6 a.m. UTC on the coronagraph C2.
And this is the one that has got the circle.
Yes.
Which you can clearly see there.
Mm-hmm. Yeah.
Just 1 second. I'm just screenshotting that. Okay.
Yeah. Now, see, this is where everybody was saying, "Oh, I could see right through it. I could see right through it." But in actuality, ladies and gentlemen, you're not seeing right through it. You're seeing these smaller objects, and I'm going to show you very clearly. Like for instance, here and here, and you're also going to see in the next frame, you're going to see 4 objects right around the top of this object. And you're going to clearly see that that is a solid object. You're going to see that these are rather large spheres. Some of them are actually larger than the planet Earth. I would put some of them close to the size of Venus, maybe even slightly bigger.
Just my the way that I've looked at this is the way that I looked at everything. When I look at this picture, I'm actually not drawn to the circle. I'm actually drawn to the planets that are inside the circle. And what I mean by that is, if you actually look at this picture, if you actually step back from the picture and try, you can actually see the circle. There's no, like you were saying, Scott, there's no 2 ways about it. There's a circle there. And why circle there? That's an interesting. That's a conversation that the doctor needs to explain to everyone. But if you have a look here, can you see that planet there?
Are you sharing your screen?
No, I'm just looking at you. Oh, hang on. I will now, actually. Hang on a sec.
Let me jump out of here and I'll stop sharing my screen.
There you go. That's the image that you just had up.
Yeah. Now, once again, folks, you know, this is just the initial image, and a lot of you think that you can see right through it, but in actuality, you're not seeing through this because it's not a transparent object. It is a solid object, and if you just hold on, chill out, wait a few minutes, we'll prove it to you.
Well, it's proven even by looking at this picture. You can see that it's not see-through because, for example, can you see my cursor?
Mm-hmm. Yes.
If you have a look at the pattern of just this particular, like, I'll call it a dark spot. It's actually laying on the image.
Mm-hmm.
It's very obvious. Like,
Yeah.
if that was see-through, that wouldn't be there like that. You know, it's laying across the image. You can actually see it. Now, what I was trying to say to you guys before is that if you actually look closely at this picture, you can see that there is actually objects in the picture. So if you look around there, can you guys actually see that image? See the object there?
Wait. Yeah, wait
Yes.
till I show you my other images. Woo, buddy.
Okay, well, hang on. Well, I'll go backwards just a bit. Now,
Yeah, I can see that object there now. Yeah.
yeah, once
The
you
characteristic central darkness with the light cloud around it. I saw that. Yeah.
right, this is
There are
actually
lots
how
of
many.
them.
This is how many objects
Yeah.
there are,
Mm-hmm.
and there's one just outside of this as well, just here.
Yes.
And Doctor, perhaps you're the best one to tell us exactly why this image was showing up so effectively with the CME. You know.
Yeah. Well, I can say that to me, even though it looks incredibly large, basically the CME allowed us to see the object and the edge of it because it's a solid object. To me, it looks like it's a brown dwarf star because it's the core of a star and it's solid. And in some of Scott's latest pictures, you can actually see that part of what we think is the CME particles is actually the envelope that this object has. I think Scott has just shown that picture. I'm sure you'll show it again later. And I was amazed to see this object actually has a thin envelope with it. It's very thin. It's not the wide envelope that we see with these objects that you are highlighting, because what happens is the smaller they are, the higher their internal energy. And then when they get older, they lose that energy and they start losing their envelope. This one has a very, very thin envelope. And like the blue-brown dwarf as well, that lost most of its, was losing the last of its envelope. It was quite clear. So this is what I see here. This object is absolutely huge. I never thought I would find one this large. This close to the sun, I must say. It's unbelievable, but it's obvious that it's not a brown dwarf. It's what I call a brown dwarf star, which is the core of a star. The sun has a core at the moment. The core of the sun is about twice the size of Jupiter. So the sun has a solid core, and eventually it will get to the stage where it will become a red giant, it will go through the white dwarf phase, and it will become a brown dwarf star, which is basically the core of the star with a few of the gaseous layers that are now part of the sun as a main sequence star. And this is what I see here. I know that people argue that it's impossible to have such a huge object close to the sun, but yet what I have seen is that these objects are attracted to the sun. It's like they are magnets attracted to each other. It seems to be all well, mostly about magnetism. It's not gravitation at all, it's magnetism. And these objects act like protons and neutrons in the nucleus. You know that a proton and a neutron and a neutron attract each other because of the strong force. And I see in this evidence of the strong force acting on an astronomical basis. And this is why these objects are attracted to each other. And then they share energy with each other. Well, the ones that have the stronger magnetic field draw energy from the ones that have the weaker magnetic field. So basically, this is what I see here. I know it's surprising. I mean, I was surprised to see such a large object there, but the fact that we see the edges on both sides tells me that it's a solid object. And a solid, it's not a, I would never say it's a planet, because I don't think a planet would survive the incredible high temperatures in the sun's corona. It has to be an object that belongs there, which is the core of a star.
Well, that makes sense.
Yeah. If you have any more questions, I can try and answer them.
Yeah.
Yeah.
This is the image inverted.
Uh-huh.
Which doesn't really, show a lot, but it does show up. Black is white, white is black.
Yes.
So it shows up that very clearly. You know what I mean?
Mm-hmm. Yes, it does.
This
Yes.
was amazing. This is actually value inverted. And at first I thought, well, this is a waste of time. But then, and this actually should be noted, you can actually see this image.
Mm-hmm.
Look.
Yes, you can see
the
edge clearly. Yes.
Very clearly. Like, there's no two ways about it. And in actual fact, if you look at it just slightly, you can actually tell that it's a solid object.
Mm-hmm. That's right.
And I know that sounds like a bit far-fetched to actually say that, but you can actually, this image here tells you that it's a solid object.
Mm-hmm.
Because why would it show up if it wasn't a solid object?
Exactly. And it has very defined edges on both sides.
Yeah, that's my point. Yeah. Which tells me that it's a solid object. So that got my curiosity even more. The picture that I showed at the beginning of the circles I started to investigate it a bit more, because I thought that Scott was losing it to start with.
You're not the only one, buddy.
Yeah, and then I just started doing what I would normally do to actually see if this image or this object is there. And as I said, as I did the value invert shows that there is actually something there. It's not my imagination. Now, this is when it starts getting into this is when I started to realize that from the original image, I discounted the fact the planet was that big. Like you were saying, I couldn't fathom in my brain that there was something that big next to the sun. So my attention was automatically drawn to these objects which are here.
Yes.
Which are the ones that I circled before. You can clearly see them in this picture. But this object here comes the size of our Earth.
Yes.
Yep. Just this one here.
I have clear photographs of these objects. I mean, the doctor can attest to it. I was nonstop yesterday with the secondary photograph, which I said is a few frames advanced. Okay, because remember, when you're looking at the C2, they squirt those images out like every 12 or 14 minutes.
Mm.
So you're not seeing things second by second or minute by minute. You're seeing them in either 12 to 16 minute timestamps. And so I started going back through it. And lo and behold, I reversed it. I went back, I went forward, and, you know, the object shows up in several frames. And then, you know, the troll factions, they're like, oh, this thing just disappeared. Well, the object's not stationary. It is moving. That's my theory. That object was in, well, we could say two ways. It was in the wrong place at the wrong time, but in our case, it was in the right place at the right time.
Mm-hmm.
And I think that it influenced heavily that CME.
Mm.
Well,
Yes,
yeah,
I agree with that. Yeah.
All right. Well, look, I've only got a few more images, but the conclusion that I came to is that this, at the end of the day, is one huge object with a system, planetary system,
yes,
with it.
Or some
there's no
type
two
of
ways
system.
about it.
Yeah, some type of system.
Yeah.
I mean, like, you know, as the doctor was saying earlier, it would probably be massively catastrophic if those other secondary objects were what we refer to as planets. If they are other stellar objects, such as stars, cores, then they would be able to withstand that distance to the sun, whereas a planet would not. Now, Prep, with your idea, you're definitely correct, because it has already been proven beyond a shadow of a doubt that these brown dwarf stars, white dwarfs, the whole entire classification of dwarf stars, they do have the ability and tend to cluster. And they're attracted to each other. And as I mentioned before, that big Harvard study a few years ago, where they captured 6 brown dwarf stars in a cluster. They captured it on the WISE satellite space telescope. And then they looked at it 6 months later, and the cluster of brown dwarfs had now moved apart from each other. And at that point in time on their secondary imaging, that's when they noticed, beyond a shadow of a doubt, that 4 of the 6 literally had other bodies orbiting around them, accompanying them, like what we're seeing. So, you know, I come to the thought that, okay, well, if those guys are seeing it, well, why the hell can't we? Do you understand what I'm saying, though? If these scientists can document it, why can't we? Now, they don't want us to document it because the damn thing is very close to our sun. That's why.
Yes. Yeah, they don't want us to look at the sun to see what's actually happening, because what we have near our sun are brown dwarf stars. And there are similarities between brown dwarfs and brown dwarf stars. And I've seen from the research that's been done that often they are observing brown dwarf stars, and they're calling them all substellar objects, because the similarities are that these objects are all emit mainly infrared radiation. But some of them are about the same size. Although brown dwarfs do not seem to go beyond the size, well, the old research would show that they wouldn't go beyond the size of 1.2 times the radius of Jupiter. But brown dwarf stars are much larger than that sometimes. As we've seen, we have some that are this size, which is a little larger than the sun, basically. So, but the research that people are doing, that the researchers are doing, I think sometimes they are confusing. They are seeing brown dwarf stars, and they are saying they're all brown dwarfs. So this is where the confusion comes from. And because these objects are many light years away, and these brown dwarf stars have, some of them are carbon oxygen core brown dwarf stars, and they have ionized gas around them. They will have a little bit at least of hydrogen left, and they can then form compounds such as water. They can have the same kind of ionized clouds, but thin and probably not covering the whole surface as brown dwarfs. So from a distance of 7 light years away, if you do a spectrographic study of them, look like brown dwarfs. And so there's a lot of confusion now, and I think people are researching these objects and putting brown dwarfs and brown dwarf stars together. Whilst in the solar system, we can definitely see the difference, because a brown dwarf is a substellar object, a lot like Jupiter, and it does have stripes, even like these objects have stripes. But these objects are old stars. They are not objects that formed as close to a star and then cooled down and became what's called a brown dwarf, which is close to a gas giant planet. So there's a lot of confusion in the research that's being done. But when you look at the objects that are actually close to the sun, you realize what they are. They are solid. And the solid means they are stellar remnants, or the cores of what was once main sequence stars. And this has been what my research has been about researching the objects that are right here, that we can observe with the instruments that we have, with the spacecraft that we have. I mean, Scott caught the blue-brown dwarf with a little reflector. So these objects are here for us to study and figure out the real laws of the universe. But yet the powers that be don't want us to look at the sun and what's happening around it. And I believe what is happening is the sun has been inundated by these objects. They come in many sizes, from the size of the Earth to the size that we now see here. And they're all congregating around the sun. Most of those specks we see in front of the object are small brown dwarf stars. So there's a huge variation in size. But don't forget, they start off as white dwarf stars, which are the size of the Earth, about the size of the Earth. And then as they get older, the gravitational field they generate seems to decrease, so they get larger. They go back to the size they were as stars. So this particular object we have here may have been a huge star somewhere that developed a huge core. It may have been 10 times larger than the sun when it was a main sequence star, 20 times. We know we have large variations in sizes in main sequence stars as well. So this could be the core of one of these huge stars once. But the sun seems to have been invaded by many of these objects. The sun's corona is full of these objects. Mm-hmm. And people have been asking me what could happen then to our sun. Well, our sun is losing energy to these objects. They are absorbing energy from these objects. These objects are gaining energy. They're getting brighter. So what do we expect to happen? Well, eventually, when we have all of them that we are going to get, the sun will keep on losing energy until it reaches equilibrium with these objects. So the sun will have the same energy as these objects at that time. I don't know how long it will take. It might take 100 years. It might take 1,000 years. We don't know. But what will happen eventually is, if the sun loses enough energy, it will start its own aging process. And the aging process with the sun will mean that it will expand and get hotter and become a red giant. And if that happens now, then it will get hotter, and eventually it will engulf the inner planets in the solar system.
Doc, I just wanted you to let everyone know, just in case they don't believe me, maybe some of you do know, that, ladies and gentlemen, there are stars out there that make our sun look like a speck.
Mm.
What is is it Arcturus?
Arcturus, yes, but Arcturus is a red giant. It's not a main sequence star, but I think it is absolutely huge compared with the sun. But I meant is main sequence stars that are much larger than the sun.
Yes.
And they can be up to 100 times larger, maybe even larger than that. So then they would have huge cores, and they would have cores about the size of this object, which is this. Well, it's about the same size as the sun. The sun has a core that is twice the size of Jupiter. So this object, it would be 10 times larger than the sun as a main sequence star, perhaps, or 20 times larger.
Yeah, right. It's definitely a big object. Prep, some of the smaller objects that are seen in your photo, whenever I share mine, you're going to see. I thought I emailed those to you. I was so busy in depth with these photos yesterday. I must have forgot to email it to you. But what you're going to see is real defined definition, and that's what really threw me through a loop this morning.
Well, the only thing I want to point out on these is, and this is for everyone's interest, that in the center is not just one planet. If you look just behind it, see the shadow there?
Yeah.
See the outline of the size of the one behind it? Can you see that?
Mm-hmm.
Yeah. There's a whole slew of objects in these photos.
There's lots, yeah.
There is. I was actually shocked to see just how many there are.
Yeah.
And if you look down here, look where the line of this massive planet goes straight through here. And these two are sitting just here. There's 1, 2, 3. And some of these here, these smaller specks, which aren't stars, some of them are, some of them aren't, they're traveling with this group on their own. The picture was, once you started getting into the picture, it was just a fascinating picture, right?
Oh, yeah. There's no doubt about it. There is absolutely, like I said, we really do have to start thinking outside of the box, just like the doctor said before. They all want us to stick to the old science, the old ways, but we can't do that. I mean, we literally need to think outside of the box, and we need to go by the actual observations that we're making. Because I'm not a scientist. That's not what I majored in college, even though I enjoy science and I've always been fascinated by every aspect of it. But we have to go by legitimate observations, what we're seeing and what we can explain. And if you try to squeeze in that old science, then you're back inside the box.
Well, just want to clarify for everyone as well. Like, if I didn't agree with what I'm seeing here, if I thought this wasn't a planet, I would definitely be saying so. But from just doing my tests and everything else, the only conclusion I could come to, it shows all the hallmarks, of being an object.
Yes.
And I tried, and this is something for everyone to understand as well, I tried everything I could think of to penetrate through, because I was interested in the fact that people thought it was see-through. So, but just look at this image here. The image is not see-through.
That's right.
You cannot see through this image. I tried everything I can to highlight this even better. And I think this is probably about the best that I got to, because you can't, it's not see-through. You can't see through it.
Yeah.
These objects here are all sitting in front of the object that's behind.
Yep.
There's no two ways about it. That's my things on it, Scott. So if you want to,
yeah, what I'll do Prep, is I'll get you
I'll stop sharing now.
Yeah, I'll get you the additional software that that I was using yesterday. I got so enthralled in it, and then you know, as I started moving through the imaging on the Core 2, that's when I started to notice that, oh my, we have some very serious definition here. So what you're looking at here on your screen right now, folks, is this is all of the work that I did yesterday in the imaging, and this does take hours on end trying to define these objects. So we're just going to go ahead and get right into these.
People must think I do it in a couple of minutes. It takes hours.
Yeah, it does.
Yeah.
Now, I'm going to zoom in here. Go ahead, Doc.
Yeah, I really like this picture. I saw it this morning and I was enthralled with it because it shows the actually thin envelope on the object. That's what it looks like, a thin gaseous envelope on it. So I really enjoyed looking at that. And we can see some of the small objects, like the one close just above the center of the screen where you see the white dot, and then you can see the kind of cylindrical structure on it. Again, that looks like the ring structure that these gaseous envelopes have around the core of the object.
Sorry, guys, and, I'm only seeing, it's kind of like a black sky at the moment.
Yeah, well, it's the bottom part of the image.
Oh, okay. Yep.
Oh, I'm sorry, you didn't see me zoom in. These are
no. Yeah. Okay.
Sorry.
Yeah. Now you see the actual object there, and you can see it looks like a thin envelope where in the center you can see the actual core of the object, which is of course dark.
Well, that's the one that I showed you that was value inverted.
Yeah. Yes, that you could see it there as well.
Yeah, that defined it more than all the other. I could just about get rid of all the other pictures and show everyone the value inverted one.
Yes,
proves that it's not see-through for a start, and it's there. It's not there. You know.
Well, I'll tell you what. If you follow me on this, because I gotta show you this.
Okay.
I'm gonna zoom in. And I now listen, guys, everybody out there that's viewing this, on your little YouTube screen, the lower right-hand corner, you're going to see a little white gear-shaped object, a little icon. Always when you're watching YouTube, click on that little gear, move the definition to high definition. You'll see a number 720p or 1080p. Based on your computer, click on the high definition. It will bring your little YouTube screen in a lot better, and you'll be able to see more defined images when you're watching your videos. Now, these videos here, or excuse me, these pictures here, I went a step further. I took these photographs, and this is all in as high as definition as my technology will go. But I also put these photographs up on my high definition flat screen TV. It was like being in a movie theater. And I literally sat on the floor and looked at these images, and I said to myself, oh my God, those are all three-dimensional spheres.
Yeah.
That's what we'll just call them for now. They're three-dimensional. They're not stars. You're not seeing through anything. Now, once again, I'll try to bring these in as much as possible. What you're looking at, look, there is 1, there is 2, there is 3, there is 4. Here's one of the objects that Prep showed you on his image. Now, it's even more clearly defined, partially illuminated by the explosion. There's an object here. Prep showed you that one also. Another object right there. He showed you that one on his image. And then, oh, now we get down here to the good stuff. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 that I can see. And
yeah,
folks,
and there are more, Scott. I just saw more. Can we go back up to where the round part is? Now, if you look about 2 o'clock around the edge of, there's the dark circular part, and then there's the cloud on the right-hand side. At about 2 o'clock.
up here?
No, closer to the edge of the darkness. Closer to the edge. There. Do you see that object there? Do you see the dark center and the circle, the lighter circle around?
Oh, yes. Now I can see, yes.
That's the brown dwarf star, but it's not as bright as the white ones. That's why it wasn't visible. And then there's another one above that. In fact, there are so many all the way around. Do you see that? There's a whole line of them.
Yes, there are many objects in these pictures. I want to jump to the next picture real quick, because what we're trying to show you, ladies and gentlemen, is the definition, how defined these objects are. Oops, sorry about that. Now, once again, we're at the bottom, so I'll kind of go slow. Here's our object. Here's the occulter. That's part of the C2 blocking out the sun. Okay, just on these objects, you can see a small glint of white right there, but then yet you can see a perfectly three-dimensional spherical object.
Yes. Yeah.
Again here, again here, again here. There's even one faintly right there, right there, right there. It's very hard to see, folks, whenever you're, with your computer screen and the, excuse me, and the stream quality of YouTube. Now we're going to move up here, because this is where it really gets good. You're looking at three-dimensional spherical objects. Here, I'm just going to point out the big ones, because there's other smaller ones there. One here, and this bad boy over here, this one's got to be huge. I would say that is much larger than the planet Venus.
Well,
clearly,
the one on the left, Scott.
Oh yeah, there's a bunch of them over here. Yeah, there's more.
That's the one. That one you've just highlighted is the one that the doctor was saying is similar to the ones that are on the inside.
Yeah.
One there, that is just enormous.
Yes,
now,
it is.
Now, once again, let's take a look at what's going on up north here. 1, 2, 3, 4. And again,
keep going past the black one, Scott.
What's that?
You keep going past the actual brown dwarf. This one, the dark one.
Yeah, there are lots of them
inside
there as well. Oh,
if you have a look at the that's not. See the one on the left from your cursor. Or this? It's massive. Look at the size of it.
Oh, right there.
That one, yeah.
Yeah.
Okay. Oh, I missed that. Oh,
yeah.
My God.
Yeah, that could be one. It could also be the surface of the solid object showing up. I also thought it might be that, because it's right at the edge of the object, you see. Or it might be another one, yeah.
Oh my, look at that. Now I see it. Right
there
where my cursor is. Look at the size of that freaking thing. See, that's what I'm saying, folks. You can stare at these photographs for hours and hours and hours. Your eyes do get trained to look for things, but having other sets of eyes, like what Prep does, and like what the doctor does, and like what I do. but getting more and more collaboration because people have different perspectives. You know, it's not all about being some Planet X freaking superstar. We're trying to figure out what the hell these objects are, what they're doing here, and what can they do. But that one, I have to say, I definitely missed. Let's see if we could just bring it out a little bit more. Oh, yeah, watch the light. Watch the light. This is the direction of the CME. This would be away from the CME. So naturally, this would be like the light side of the Earth, the nighttime side, the daytime side, the nighttime side. Watch as I increase the exposure, what happens. It lights it up.
I'm actually starting to think the same as the doctor, actually.
Yeah, she's very influential.
That image to me looks more like the surface of the object more than another object.
Yeah, I thought it was that. But there are so many. It's just this whole object is just covered in brown dwarf stars, the smaller ones. So we have smaller ones around the large one. It's just amazing.
I've got a
so
question
they're all
for
over
you.
the place. Yeah.
I've got a question for you, Doctor. Someone's asked me a question to ask you.
Okay.
One second, while we're looking at Scott's fantastic pictures. You did a good job on that, mate. It looks good, actually.
Yeah, I'll shoot these over to you whenever we're finished, and you know, you could examine them a little bit more. But yeah, this definitely came out pretty damn good as far as showing that it's a solid object. It almost seems that for instance, this black area that you see, it's almost like this is a gaseous area belonging to this object,
Yes,
not part of the CME.
Yes, that's what I said as well, Scott. The moment I looked at it, it looked to me like the gaseous envelope surrounding the core, or the object itself, because it is the core of a star, and it's black. It's not emitting light. So if we could see it in visible light, the chronograph does not actually allow us to see like through a telescope. It
Exactly.
might look like it's striped, like the blue-brown dwarf. If we could actually have light reflected off it, so it might look striped. But in the chronograph visible light image, it just looks black because it's not emitting anywhere. It's not emitting light, basically. It may emit infrared, but not visible.
Here's the questions for you, Doctor.
Yes.
This is from Mike in WA.
Yes.
He's got 4 questions for you. The first one is: could these bodies be gaseous bodies?
From what we've seen of the blue-brown dwarf, they are solid.
Okay.
If they do have gas around them, like their gaseous envelope, like all stars, they produce a core and then they have many layers of gas around them. These ones are basically a core with a thin gaseous envelope. And the smaller ones, the gaseous envelope is larger, but it's not shaped like the gaseous atmosphere of a planet. It's ring-shaped and usually on either side, or like a cylinder around the object and partially covering it. So like this one, we see on one side, we see right to the core, and then surrounding the bit of the core that we see, there's gas around there.
Okay.
So that's the gaseous envelope. So no, they're not gaseous. They are solid objects.
Okay.
And we expect the core of a star to be solid. We expect a white dwarf star to be solid and very dense.
Yep. Okay.
Yeah.
Next question.
Yeah.
So on the same sort of line, he's asked, if it is a gaseous body, would these bodies be able to be ignited by an extreme CME?
Yes.
Traditional magnified CME, what are the physics behind a gaseous body?
Yeah, what happens is, as these objects gain energy, they are able to ionize more and more the gaseous envelope. This is how all stars operate. They ionize the outer layers of gas, which then you get arc discharges, and that gives off light. Because basically it's plasma discharges. It's like what happens in a cathode tube or a gas discharge tube. So some light is emitted depending on the gas that you have in there. So these objects then emit light from the gaseous envelope because they are ionized strongly enough to have these discharges. But eventually what happens is the energy gets to a certain level where you can start having, from the bottom, right on the surface of the star, you start having fusion reactions. And I don't mean hot fusion. These are cold fusion reactions that are powered by the electric potential energy of the object. So you start having these reactions, and some of them I've seen in the HI images, the stereo images. They get very bright for a few days, and then they seem to get very large and very bright. And that is a characteristic of white dwarf stars. When they absorb plasma from another stars, sometimes a fusion is ignited for a while, and they get very bright for a while and much larger. And that's usually called a nova outburst. It doesn't mean the whole star exploded. What you suddenly have is a flash of fusion happening on the surface of the star, which makes it much brighter and look much larger for a while. It's not a supernova at all. The star doesn't explode. But these objects are so much smaller that the nova outburst is not that large. I mean, it's enough to maybe make the star look, or the core of the star look 5-10 times larger than normal. So this is the type of thing that happens to these objects.
Okay, well,
I hope that answers that question.
Yeah,
yeah, that answered it.
But
yes.
Okay, I'll go on to question 3, but I've actually got it. So, if the CME, this is a question in myself, I was just thinking about what you were saying. If the CME was big enough, which it was, I suppose what they're trying to ask is, why didn't the CME blow these planets up?
Yeah, because,
for example.
All right, they are not planets. That's the thing. This is the core of a star.
Yep.
The sun itself has a core like this inside it, and it's got all that plasma around it because it's a main sequence star. Its core is very small compared with all the gas layers that it has. It's only 0.2 of the sun's radii. So it's 20% of the size of the sun. You realize that. So the sun has huge amounts of clouds of gas surrounding its core. But these objects don't have as much. They have a thin envelope. The smaller ones have a wider envelope. But when they get enough energy, they start operating like normal stars. They ionize whatever's left of their gaseous layers enough to start glowing and having fusion reactions like a normal star. That's why I then call them rejuvenated stars. So what we have is one star inside the sun's corona and in the environment where they are CMEs. Some of these objects actually start having their own CMEs because they get to the point where they can accelerate large amounts of particles from the surface, just like a normal star. So it's not destroyed by it. It belongs in that environment, if you know what I mean. It's where it belongs. It's a star. It's the core of a star.
Yeah, it's like the reverse of a fish out of water.
Exactly.
I just, Doctor, something that you just said in your explanation.
Yes.
It just hit home with me right now. This bell just went on inside my head. Prep, you know what she's trying to explain, and you know she's a scientific person. She does a good job at putting this into layman's terms for us.
Mm.
But if you understand the makeup of Jupiter, everybody, when you look at Jupiter, it just looks like a big solid striped ball. But in fact, those are very, very heavy layers of its gaseous cloud and cloud formations. And scientists, they did drop that one probe down through all of these layers because we still don't know what is under all of those layers that make up Jupiter. So now it hits home when we're referring to the size of this object. So what I'm trying to say, ladies and gentlemen, if you take away the entire gaseous cloud region of Jupiter, then we would really see what is at the core. Am I correct in saying this, Doctor? Am I explaining this the right way?
Yes, you are. All stars and most planets, and I think Jupiter will have a solid core as well because it produces a huge magnetic field. And usually you would need a solid core and a liquid around it to produce that kind of magnetic field. So I think Jupiter will have a core as well. Like the Earth has a core. The Earth has a solid iron core, and its density is about 13 grams per centimeter cubed. But these objects have their densities about 100. The Sun's core is supposed to have a density of 150 grams per centimeter cubed. So you can imagine that the cores of these objects are much denser than the core of planetary objects. So this is how dense they are. They're extremely dense solid objects.
So Doc, let's just get this real clear for everybody.
Yeah.
Even though we're looking at this massive object.
Yes.
Thinking outside the box, like I was saying, referring back to the planet Jupiter.
Mm-hmm.
I mean, if we stripped away the entire cloud surface of Jupiter, we're going to get down to close to the core of what that planet makeup is. So then it's not going to look like Jupiter anymore.
Exactly. It's going to look like a solid object about twice the size of the Earth, perhaps.
Exactly. But Jupiter, from our perspective, looks like a solid object when in fact, you know, Doc, I mean, we don't even know what the surface of Jupiter looks like.
No.
So it would be hard for us to assume, if you stripped away the cloud cover of Jupiter, how big is that object? So Prep, that just hit me smack dab right between the eyes when she was explaining it that way, talking about the cores of these objects. So that just brings a lot to light to me. Wow, that just turned on a freaking light big time.
That's good.
Okay, Doctor, I've got two more questions.
Okay.
Are these bodies in motion or static between the 17th of the 7th and the 24th of the 7th? The CME from Soho shows same bodies in same place.
Yes, they do stay in the same place for a long time sometimes. It's like when you have two magnets and you have the North Pole and the South Pole, then the South Pole will attach itself to the North Pole of the other object. And it will stay there for a while until something moves it. And I believe that's possibly what's happening with these objects. They are so attracted to the sun. They go as close to the sun's corona as possible, and they stay there. They stick there until something happens. Of course, the sun is producing CMEs, and these objects, I think, are destabilizing the sun's surface magnetic field, which makes the CMEs stronger. because the sun is less able to pull on its gaseous cloud towards its surface. So it destabilizes the magnetic field and allows increased acceleration of particles away from the sun's surface. So, and then that changes the magnetic field, and when the magnetic field changes, these objects may move in response to that magnetic field. So possibly this is what happened to this object, that the sun's destabilization when there was the CME actually changed the magnetic field to such an extent that this object responded to it and moved away from the sun.
Okay.
Yeah.
Mainly because of the explosion?
Yeah, but it's all magnetic. These objects connect to the sun magnetically. Okay, so they will respond to a changing magnetic field on that side of the sun.
Okay.
Yeah.
That makes common sense, but I suppose the wiring, the worry out of what you've just said is that people need to understand that as long as this thing's there, then these CMEs are not going to stop, and there's even a bigger chance that they may get bigger. We may have an enormous CME.
Well, see, that's what I was talking about this morning, Prep.
Yeah.
That's what I'm worried about, is because we just had another CME this morning. It was pretty decent. However, the footage got cut off because of the timestamp. Yeah. So within the next 4 to 8 hours, we'll get the full vision of what that CME was, but it is coming from the AR-2665.
Yes.
On the SDO image this morning in my live stream, I showed some massive flaring coming from this AR-2665. The problem is, in the next 10 to 14 days, that CME is an equatorial equatorial sunspot. Okay, so the Earth sits just below the equator on the sun. We're going to be in the bullseye, the crosshairs of that damn thing again. And if it's reacting the way that it is now on the backside, oh my God. Okay, so once again, we now have to worry when it turns Earth facing again. And it is coming.
Yeah.
I don't care what any scientist or nerdy astronomer has to say. These people downplayed this damn sunspot all the way till the first CME occurred. And thank God that it was just off of being Earth facing, or we would have had a shitstorm here on Earth.
Yeah.
And then the second one, and then now this one on the 28th. So that's my point.
Yes.
You know, it's a good point, and it's a good thing to worry about.
Yes, of course. You know, and I always say, listen, folks, this isn't the matter of some rogue planet coming out of nowhere and smashing into the Earth. Like, I see all of these Nibiru channels and videos, you know, oh, you have 24 hours, Nibiru is going to hit the Earth, blah, blah, blah. No, that's not the case. The fact of the matter is that our biggest threat, and I have said this time and time again, is going to be the interaction with these objects with the sun and the sun's reaction to these objects. And if we're in the wrong place at the wrong time, yes, we could have a life-ending event on this planet. Scientists will agree with it. Hey, they produce their videos, National Geographic, the History Channel, the Discovery Channel, NASA, all of them have put together their own productions pertaining to kill shots, CMEs, you know, all of these big solar bursts. Yeah, they can fry the Earth. But now that you have all of these other characters in the inner solar system wanting to, you know, react with the sun, well, you know, the sun doesn't want to play. So it's going to have a reaction. And that reaction is what we've been seeing now for over a year and a half. All of the massive coronal holes. The coronal hole that has stayed on the north pole of the sun, the top of the sun, then on the bottom of the sun, then combined, then a whole third of the sun facing the earth is one big massive coronal hole. 865,000 miles of a coronal hole. If you look at it through the X-ray, the GOES satellite X-ray of the sun, it proves it to you.
Mm-hmm.
Right, I've got one last question, Doctor.
Sure.
Okay.
Can we decipher as to what type of a body it is, apart from spherical and definitely there, i.e.
Well,
solid mass? Can we test
yes.
for its makeup? Gas, chromatograph,
like I said,
reading.
all right. So in my book, I'm actually calculating the density of some of these objects, and they are close to the density of the sun's own core. So we can estimate its size because it's close to the sun. What would it be? 1.2 times the radius of the sun, and then we can through the density we could calculate its mass. But I have reached the conclusion that these objects, it's not as easy as that. Mass is not just something that you're going to, okay, find the density, multiply by the volume, and calculate its mass. It doesn't actually quite work this way anymore, because these objects seem to generate a gravitational field, which then gives them a mass. And the field they generate is dependent on how much energy they have. So even though, I mean, I calculated the density of one of these objects, but it was much smaller. Its radius was about half the size of Jupiter. So I'd expect it has a higher density than this larger object. This one may have a much smaller density. It may have a density even closer to the Earth's density. Probably not, probably a bit higher. So if I knew its density exactly, I can estimate its size. Usually if I see one of these objects actually drawing plasma from the sun from a certain distance, I can then use that and model it and say, okay, its gravitational generation abilities is in step with its magnetic generational. So then this is what I use to estimate the size and the density. But with this object, it's difficult because all I can really see is its size.
I've got just one final question.
Yeah.
We know a couple of constants.
Yes.
Speed of light, distance from sun to earth, time at which CME occurs.
Yes.
By using at least 3 sources, Secchi, SOHO, LASCO, etc., we can triangulate said bodies in question as a CME event will be highlighted by its sources. This is a timestamp to work with.
Yes.
Once triangulation occurs, we can identify time from CME ejection, to highlighting of said body. Knowing speed of light is a constant. This will give distance from sun to objects. Since we know the size of sun and location of bodies, we can now calculate size of body in ratio to sun.
Yes, I mean, that's not a problem. An estimation of its size is not a problem. It's close enough to the sun for me to say that it's, well, it has to be, according to this image we're looking at, which is the SOHO spacecraft, which is at the Lagrangian point 1, which means that it's actually in front of the Earth facing the sun. We know the CME was directed backwards towards Mars. So the CME is not towards Earth, it's it's backwards away from Earth. And the fact that the CME hit the object means that the object had to be on that side of the sun, but very close to the sun. But it's so close to the sun that any distance at that point does not actually change the estimation of its size by much. So basically, just by looking at the image and comparing the actual size of the object, we can assume it's right there at the sun. Okay, so then we would give it a radius. I haven't actually measured it. We can compare it with the radius of that white circle there. It's slightly larger. So I would say 1.1 to 1.2 of the radius of the sun.
Okay, yeah.
Okay.
Okay. Perfect.
Yeah.
Prep, do you see the size of this CME this morning?
Yeah.
Now the video footage from C2 has updated. We've moved forward in UTC time, so now we're getting the footage. Take a look at that. Take a look at that, people. And again,
wow, that's another large one.
And again, yesterday, you know, I reported on this sunspot continually venting. And as it's venting, there's even more reaction. And then look at this. 16 hours later, maybe 24 hours later, massive CME. Thank God that one wasn't Earth facing.
Yeah.
But this monster's coming back around in the next, I would say, 10 to 14 days, and we're gonna deal with it as it crosses across the face of the sun where we're located. So once again, the odds of another coronal mass ejection in the days that that sunspot is visible to the Earth, it's going to be a time to pray. Now, that's my opinion. I don't know about all of you, but you're looking at it right there with your own eyes. You've already seen 3 or 4 huge CMEs. What is that I keep seeing flying in front of the?
Yeah, well, that's one of the.
Oh,
That.
see that?
What the hell is it?
Yeah.
No, I'm just saying, can you see the size of that body
Yes, it's huge.
next to the
There's
sun?
just so many. Yeah, right next. Yes, I see it. Well, it could be one of the planets, but
The hell is that below the sun?
mm.
And it's only there for one frame.
Oh, if it's only there for one frame, it's one of these objects. You know, the brown dwarf stars probably, or some debris.
That was weird. Yeah, you know, folks, if you slow the coronagraph down.
No, I was just looking at that. Just go back to it again, Scott.
Yeah.
Keep going. Keep going. Keep going.
I see some of these objects are moving away from the sun. Amazing.
Stop there.
Mm.
Can you see right at the 11 o'clock position?
Yes.
You can see.
Oh, there we are.
That?
Yeah.
Ooh,
Yep.
Oh, we have to take a closer look at that. Hold on.
More of them. I actually saw lots of these white specks move away from the sun as the CME happened. So it looked like white specks, but as you know, these are probably very small brown dwarf stars moving out with the CME.
That's an object.
Look there. Look right here.
Look at that, yes.
Yeah, we're going to
lots
have
of them.
to, you know what? I got to screenshot that real quick. We're going to have to take a closer look at these images during this coronal mass ejection, because folks, you know, these coronal mass ejections, they're lighting things up. I mean, this is like our flashlight, man.
Yeah.
Look, there's one right there.
Yeah. they were actually moving out. Some of them moved ahead of the CME outwards from the sun. I could see it. It looked interesting.
Scott, can you take the image out again so I can screenshot it?
Yep. You want me to, you just want the full view?
No, that's it. A little bit. Can you make it a little bit bigger?
Yeah.
Look at that.
Yeah, there's some stuff there. I think I could see a few things even with my screen not blown up. And again, folks, listen, whenever you're watching these videos, my advice to you on your little YouTube video player that you have on your screen, go to the lower right-hand corner, click on that little white gear, and set your visuals to high definition. You'll see the number 720p HD or 1080 HD. Move your cursor up there, click on one of those, and you'll get a better full definition, higher definition on your computer screen and for YouTube.
Okay, this is amazing.
Yeah, I could see these objects without even doing any work on the photograph.
Mm-hmm. Yeah.
Because usually, folks, whenever you see objects, the little tiny white dots in the C2 coronagraph, usually you're looking at objects that are far, far away in the back regions of space. You know, those little tiny objects are stars. But we're actually seeing three-dimensional spherical objects illuminated by the CME. They're clear as a bell. Matter of fact,
They definitely are.
yeah. I'm going to zoom in here real quick, Prep, because I want to take a look at one of these. Give me a second here. There's one right there, right where my cursor is. Clearly within this CME.
Mm-hmm.
I got to get a screenshot of that too. Hey folks, you're sitting here, you're watching live research and investigation right now. This is how we capture these little buggers.
Yes.
What do you think, Prep? We're going to have a lot more homework to do later on today, huh? Well, it's your nighttime.
Well, it's 12 o'clock here now, so.
Mm.
Oh, so you're into the next day.
Yeah.
I'm in Saturday already, mate. Okay.
Yeah, it's very interesting.
God.
Very, very interesting.
I honestly can't believe what I'm seeing these days.
Mm. I know. There's so many. And everywhere in the inner corona, in the outer corona, they just
yeah, I'm going to switch over to the C3 real quick because I'm just kind of curious.
Mm-hmm.
Mm-hmm.
Yeah.
Once this pans through, that's a pretty big explosion, man. I mean, that's
it is.
You know, you could literally just see the burst as it starts to come out slowly, and then that final burst. I mean, listen,
Yes.
that's a lot of energy, man.
Yes, it is.
You know, and these immediate bursts, folks, they travel millions of miles an hour. A coronal mass ejection can eventually reach the far corners of our solar system. We're only 93 million miles away, so you know, it reaches us. Trust me.
Yeah.
I want to zoom into this because the C3 gives you a little bit of a further viewpoint. So I just want to zoom into this just in case, and I want to see a little bit more closer up.
Oh my God. I actually can't, I just cannot believe what I'm seeing here at the moment.
Uh-huh. You see the huge numbers of these objects. Huge.
Like, it's just bizarre. It's just crazy.
Yeah.
Why are they not letting us study these things? And, you know,
Because they think that the whole world will panic and they would lose control. That's
Hey,
what
guys.
and we would start telling them, what are you doing about it? What, we are in danger of losing our power grids. And what are you doing about
Oh my God.
You
Prep.
see?
You got watch people where my cursor is.
Mm-hmm.
Watch the line of objects coming out towards you.
Yeah, yeah, that's what I see. They come out from the sun. Exactly. Look at that. They spewed out of the sun.
Yeah,
Ahead of the CME.
I'm gonna slow that down just a little bit more. You can clearly see those objects are moving away.
Yeah,
right there. Right there again. Yeah. Prep, that's that same line of objects. Watch that very clearly. 1, 2, 3.
Yep.
Ooh, my. Ooh, this is damning.
Yes, it is.
Yeah, this is damning, man. I mean, I don't know about you guys.
Yeah, this is amazing.
1 second, I'll be back in a second. I've got to have a toilet break. And then I'm going to show you what I found on that image.
Okay.
You want me to stop sharing my screen?
No, you're right.
Yeah, I'll be looking into these photographs later on. It's a little harder to bring out some detail, folks, on this C3 coronagraph, but the C2, the red one, you could definitely capture some decent definition. Very interesting. Yes. I'm sure as we get more footage, that's going to come through a little bit more. I'm going to flip back over. This is the screenshot that I just took, folks. So let's just edit it right here.
Mm-hmm.
Just get the clarity a little bit better. Let's get our lighting a little bit better.
Yeah, we're starting to see more of them.
There you go.
Yes.
That was just done live on the Nibiru channel, right in front of your eyes, folks.
Yeah, it is starting to see, you know, you see the light spots, that's the small ones. And sometimes you see the dark little patches, which are the cores of other ones with clouds around them. There are so many, Scott.
Oh, yeah.
There are just so many. It's just all over the CME. It's unbelievable. Oh, my goodness.
Yeah, we're going to take a look at this in.
I'm back.
Yep. Well, there you go. Yeah, Prep. I was just doing some live editing right there on the two objects that we just saw right there.
Yeah, you see the two spots there, and then you see a larger one. You can actually see the black dot and the circular cloud around it just beneath that.
All right. Well, I'll show you the same ones, but I've got them on.
Let me get out of here, and you can take over the screen there. It's all yours, brother.
Can you see my screen now?
Yep, we got your whole chalkboard there.
Right. So that's the same images that you just brought up, Scott.
Yeah. Yep.
But you can clearly see this one here. There's a cluster there.
Oh, yes.
There's another huge object here. There's another one just there. And there's one down here as well.
Yeah, I see that also. Can you zoom in on those a little bit more? Oh my, see, once again, you're looking at a perfectly spherical shape.
Yes.
Which is not possible in an explosion.
No.
Yeah.
And this is bigger than I thought, actually, these ones here. That one's the same size as this one. This may be the two that we were looking at on the other image that you found, Scott.
Yeah.
But that's one. Let me go to the other ones. Hang on. The other ones came out better. This is interesting. This is inverted.
Yes.
So there's one there. You see that?
Yeah.
That's one there. Interestingly, it showed up those two.
Yep.
Yes.
Although that other one is, those other two are there. And then look at this one.
Wow.
Yeah, there's another one. There's another one under the black flame coming right below your cursor. Drop
around
down.
here. Yeah,
Right
I saw
below,
that.
right below the black flame, there, right there, where your cursor is. That little.
Those three.
Yeah, a line of three.
Two.
Yes.
There's three in a line there.
Mm-hmm.
But look at the size of that thing. That is massive. Now, wait, you see this one.
Yes.
Was this the one? Or was the next one? Oh, this is
Oh
just.
my! I could see the one under the black flame. Well, the white, sparkly little.
Look, see
that
those
thing-
ones?
Yes. Yeah, I see them. Wow. Look at that.
And-
Oh my.
Doctor, you'd be better at telling people
Mm-hmm.
as to these objects should not be this close to the sun, should they?
No, I mean, well, we know they are there. These are all brown dwarf stars. There must be thousands and thousands of them now.
You know,
That's what I.
You know, the way that I was
so
thinking.
many.
Yeah, the way that I was thinking the other day, and you know, this is what I was mentioning earlier, folks. Knowing that you know, we're passing through space. We're just a little tiny solar system on the outer reaches of a galaxy. And as we pass through space in our galaxy is passing through space in the universe. So what makes you think that through time, you're not going to come across some other things at the end of the street.
Exactly. Oh my, look at that.
That's just an impossible way to think. So as we're moving through this vast thing we call outer space, eventually we're going to come across some things maybe that we've never seen before. So again, thinking outside of that box, that yes, this is all possible. We're actually documenting it right in front of your eyes.
Yeah. Yeah, and I just want, sorry.
I was going to say to you, in retrospect, that black dot there would be a similar size from Earth to the sun, wouldn't it?
That's right. It's about a lot of these objects are about the same size as the Earth. But
so
that's
this thing that we're looking at here,
yes,
that is just enormous.
Yeah, well, there's a huge variation in the sizes of these objects, but then there's huge variation in the size of stars as well. So what do we expect? And don't forget that 90% of all stars are expected to become white dwarfs. So a white dwarf eventually becomes a brown dwarf star. So if you have 90% of all stars, and we have billions of stars in a galaxy, can we not expect to have large numbers of these objects that were once main sequence stars and have gone through the white dwarf stage and are now brown dwarf stars? And I have addressed the problem that people say about white dwarfs take too long to cool down. And I just want to mention again that all stars are not hot on the inside, they are cool on the inside. And what we have seen with the sun going dark proves that. And the fact that sunspots are cool and dark as well proves that the sun is dark on the inside. And therefore, all stars are very likely to be dark and cool on the inside, including white dwarfs. And therefore, they don't take all that long to cool down because they're not hot on the inside. They lose heat mainly from the surface, and it's the surface that's hot and glowing. So plus, as I mentioned before, the Big Bang model, as far as I'm concerned, has been falsified. So this actually, the universe could be infinite in age.
I agree.
No doubt about that.
I want to point something out to you guys. I noticed on another one, but I thought it was an actual blip. Can you guys see that there?
Oh my goodness, yes. It's superimposed on
the
digital background, which is digital, as you mentioned.
There's another one there, and I just realized that it was on the other picture that I was showing you.
Amazing, yeah.
Look, there it is there.
Wow, they even show through the occulter. Unbelievable.
That's an object.
Wow,
that's
that's crazy there.
Yeah.
That is crazy. I'll just go to the inverted ones and see if it's on the inverted ones. No, it doesn't come up. Have a look at this one. No. Yeah, it's definitely there. Look.
Yeah.
This is the original.
Yeah, you can see the dark spots associated.
How's that possible?
And the lighter parts. Because yeah, it is possible, because I also saw the same thing happening in the stereo images, where I actually saw plasma ejections superimposed on what they call the baffle, but it's obviously digitally generated. And you can see flashes of particles superimposed on it. So it's the same thing here.
Yeah, it's definitely there.
Wow.
Guys, it's 20 past 12. I've just got
Okay.
one thing that I want to share with everybody that I found today. If you just bear with me.
Mm-hmm.
I'll stop sharing for a second, Scott, if you want to show your pictures.
Oh, mine looks like my computer wants to freeze.
Oh.
Okay.
Okay.
I'm back again. Can you see my screen still, or is it stop sharing?
I can only see your avatar at the moment, so you did stop
Okay.
sharing.
Right. I'll fix that up.
Yeah,
Hang on a sec. Okay. Is it?
Yeah, you starting. You just
Yeah. For some reason it froze. Then I don't know why.
I don't know. I think Scott was also having a problem. Well, someone doesn't like us looking at these images, Alan. Yeah.
Well, you're a conspiracy nut.
Yes, well, as Scott says, this is the biggest cover-up in the history of the world.
What's going on here?
I don't know.
Right, I'll stop that and I'll start again.
Okay.
Is it doing it or what?
Yeah, well, it looks like you're starting to share and then... Oh.
Okay, everybody, I'm back.
Oh, okay, good.
So it was Scott that was.
Yeah.
Okay, Scott, I'm
They
going
kicked
to
me
show
out of my own
you.
live stream.
I'm going to show you something, and then I'm going to bed.
Okay.
Yeah, he's trying.
If it works.
Yeah, if it works. I don't know why it does that.
It's telling me I'm screen sharing, but it's got this.
Yeah.
And I'll start again and see if that works.
Now, I think you are screen sharing. You just have to then press on the window you want to show. You were. Yeah.
Okay.
Now,
I'm screen sharing now, yeah?
Yes, you are.
There you go.
Here we go. Right. This is a video from Neil Oakley that was done yesterday on the 27th of July.
Oh my.
Look, everybody needs to watch this video. I just can't say how amazing this video is. I'm going to take you through it. I've obviously got screenshots from it. Hang on, I'm trying to get to the one. And then I'll show you the image live so you guys can see it, which is here. Okay, this is live, folks. So this is, I want to prove to everyone that this is actually real, and this is what we're actually seeing. So this is a video from Neil Oakley, who's in the United Kingdom. He's in Liverpool, actually, in England. Now, he filmed this yesterday and uploaded it. And as you can see here, there's, you know, there's bloody planets. This is a reflection, lens reflection. But there's planets everywhere. And like I said, I'll show you those in a minute. But my main purpose here is to actually show you what I'm about to show you. Okay. And you are going to say, yeah, I don't know what you're going to say, but I'll start it from here.
Yeah.
Just watch the sun closely. Have you got this, Scott?
Oh yeah, I saw the video this morning.
Right.
Amazing.
Do you know what I'm going to show you?
Yeah. No, keep going. I want these people to see it.
Did you see that?
Yep.
Wow.
Doctor, did you see that?
To tell you the truth, I'm not sure what I saw.
Right. Okay. I'll do it again. And then I'm going to press stop so that you guys know that it's actually true. Okay. I'll turn off the volume. Keep watching the sun very closely.
Oh my.
Did you see it?
Yeah, is that something on the sun? Oh my.
No, watch this. I'll play it slowly. I'll do it how I do it when I review them, okay? So watch this.
Okay.
Look in this direction. Can you see them?
The objects there. Oh my.
Can everybody see that?
Yes. Wow.
Now, I can account if I can account for this. This is a lens flare.
Yes, that's right. But all the other multicolored.
Now, a lens flare is going to give you this, and I can probably discount one of these others, 7 planets, object things that are here.
Yes.
Now I'm going to show you the what it looks like. On this. I nearly fell out of my chair when I saw this today.
Hurt yourself. I had a bunch of those moments yesterday.
Sorry, I got the wrong one there.
Oh, we're starting to actually see the clouds. Oh my goodness, look at that. Dark hole with a cloud around it. I see it all over the place.
Look at this.
Oh my goodness.
Somehow, and I honestly can't figure this out. I'm not sure how that's coming out at your end, if it's blurry or.
It is a little blurry.
Slightly. Yeah, it's slightly, but if you go back to the video, if you go back to the original video prep and you increase that that resolution to 720 or 1080, when I watched Neil's video this morning, that's what I did. See the little gear Click on that. Click on where it says auto at the bottom. Take it up. Oh, that's all he's got. Okay. Yeah, that's all he's got on this. Click on that 480.
Yep.
And that's it right there. But I can get it in 720 and 1080, which is a little more finer definition. But even at that definition, I could see that clear as a bell looking right on my screen.
There's lots of them.
I cannot. I actually can't tell you why it's there. You know, like it's 100% there.
Yeah, the thing is, the sun's corona is now almost completely saturated with these objects. Well, it's not completely, but there are just so many in the sun's corona and further out. The inner solar system seems to be filled with these objects. The closer we get to the sun, the more we are getting. Well, the number density increases. But obviously, the area around the sun is full of these objects, and this is what we are seeing. This is just evidence of that fact. And the thing is, like I said before, these objects are draining the sun. And eventually, if the number of objects coming in stops, then the sun will reach a point where it will be in equilibrium with these objects. But these objects are not leaving the solar system. They are a part of the solar system now.
That is just amazing.
It is.
It looks a bit blurry, but you can actually see a bigger one here.
Yes, that's right. I can see that.
So
oh my.
This is not made up, folks, and it's not put on there by anybody. It's definitely there.
Yeah.
And the other weird thing is, when I tried to test it, I couldn't, because it's actually in full-blown color already.
Okay.
I hope everyone understands that. These are in full-blown color. That color that you're seeing there, the yellow, the blue, the sort of greenish bluey, the black at the back.
Yeah.
And this thing here, all as they are. I haven't touched them.
Yeah, so this is the actual visible light that these the clouds of these objects is emitting. It's unbelievable. Yeah, so that's what we don't get in the chronograph images. We don't get their true color, which we will get when we look at them through a camera or through a telescope. And this is amazing. So this is also why. Yeah, the Earth is being illuminated by these different colors, magenta, orange, burnt yellow, because these objects are emitting this color, and they are illuminating the Earth's atmosphere at certain times, the ones that are closer to the Earth, I think.
I'm going to play the video again, just so everybody can see. What happens is these things are here. They are there.
Yes, they are.
Sorry. They are there. So, but then watch what happens as the sun dissipates. But that is just amazing.
Yeah, it is. It is amazing.
But that's not the only thing I want to show you from this video anyway. I'll show you just one other thing and then I'm going to bed. What originally drew my attention to the actual video was at the beginning. Was this object up here. You can't see it much there, I'll keep going.
Mm-hmm. Oh, you see that part of the sun that seems to be occulted.
Yeah,
Yeah.
yeah, it's like blocked.
Mm.
Now, there it is. This is the one. There's two things I want to show you. This thing here, and you know, in actual fact, right through the video,
Excuse me.
there is planets everywhere, objects everywhere.
Yeah, that's right.
But I want to
can
show
see
you. I
that
want to show you
one.
this particular one.
Mm-hmm.
Hang on a sec. I think I did some.
Excuse me.
Did I? Look at this object.
Oh my goodness. Yes.
Look.
I see it. It actually looks like it might be two of them. Because
Well, I wasn't sure, but it's
yeah,
definitely got wings.
one above the other. Amazing.
Excuse me.
Now, this is the thing that I wanted to show you guys as well.
Yeah.
I couldn't figure this out for the life of me. Can you see anything weird in this picture? Hang on a sec.
Yeah, I can see the dark shadows that don't seem to belong there. I saw some dark shadows in the clouds.
Oh my, yeah, you could see that.
Yeah.
Can you see anything weird there in that picture?
Yes. Oh my.
Have a look at this thing here.
Yeah, that's one of them, and there's another one below them, and there's another one to the left.
Yeah.
And now
That's
you know.
right.
Now watch.
Now you know why they chemtrail.
Yeah, exactly.
Now,
You know,
now watch.
your freaking
Now
clouds.
watch this. Sorry, wrong one. Oh, there it is. Sorry. Watch this.
Oh my goodness, there's so many.
Can
All over
someone, anybody, tell me what this is?
Oh my. Oh
Yeah,
my.
that's one of them. It's
Woo!
absolutely characteristic presentation of a brown dwarf star. The hole in the cloud through which you can see the core of the object. Amazing. Yeah.
Either that or that's one big hell of a UFO, but you can see the glint of light on the left, upper left-hand side of it, the lower shadow on the bottom, clearly defining it as something spherical.
Yeah.
I don't know how much more you could. It looks like there's a smaller object in front of it.
Yeah, that's what it is. It's a large brown dwarf star with a smaller one in front, Scott.
It's casting it's even casting what looks like to be a shadow.
You see, this is how these objects almost stick to each other. They are so close to each other. They are not just attracted to the sun, they are also attracted to each other. It's like having a whole lot of different magnets. It's unbelievable.
You know, ladies and gentlemen, you are getting firsthand Planet X research and investigations. I mean, this is what it is. I mean, this is exactly what it is. It's constant observations, digging, using a little bit of technology, but you have to put the time in, and you have to have some resources. Prep does a fantastic job at eyeballing these. That's
Wow.
an impeccable image.
That's amazing. Wow.
Is there anybody out there that, you know, this image is the one we here in Australia in the leadership group, Nibiru leadership group, we call it the pimple, because we've got image after image after image of this that looks like a pimple.
Okay.
Yeah.
Yeah.
And I finally got a real picture of it.
Yeah.
But there's no two ways about it. That is 100% a bona fide planetary body, or two. Sorry.
Yes, it's two objects. It's a large one you can see by the dark hole in the foreground. and
Yep.
that's the large one with its own
Yep.
envelope around it, and then there's a small one in front of it, and it does make it look like a pimple. You're right.
That's clear as a bell. Hey, listen, real quick, everybody, everybody in the live chat there that needs Prep's YouTube channel link, just go to my YouTube channel, and over on the right-hand side, you'll see featured channels. His channel link is right there with his logo. Click on that, go right to his channel. Simply subscribe, set your notifications, check that box, and set it up. It's all right there.
Thanks, guys.
Yeah,
Okay.
yeah, not a problem.
On this-
Hey, real quick, Prep, before you go, I had a couple of more photographs. I just wanted to show you and everybody else. These just came in this morning from
Yeah, go on.
one of our subscribers, Adriana, and these are coming from the Azores. Now, you know, take into consideration these are coming from. I'm going to go ahead and share my screen real quick, and these pictures are pretty freaky. Once again, if you want to call it that. Just zoom in on here real quick. Now, these are coming from cams. So, you know, you're always going to see some type of a weird glare here or there. But
Mate,
you see
I'm
the
going
sun.
to do I'm going to call it Punters Pictures on Sunday, because I'm getting images that I cannot even believe, to be honest with you. There's just, I've got so many images from people from around the world
Yeah.
of late that are just mind-blowing,
Mhm.
just absolutely mind-blowing.
Oh my goodness, look at it. The magenta colored object.
And they say, and when you start to see it from Earth, well, this is coming right from the Azores.
Uh-huh.
Adriana, she sent me in about a dozen photographs of this object. There always will be the ones that will say, okay, that's a lens flare. But as you just looked at the other photograph I showed you, it's, how could you have a lens flare behind the freaking sun or behind the cloud?
Exactly. It's not a lens flare, that's for sure. Plus,
Scott,
I mean, look.
mate, can you go back to that image? Just hold that image just there for a second.
and there's a brown dwarf star to the right. I can see it. They're all over the place.
Hold on 1 second. I just wanted to do one quick thing.
The little spot there.
Just making sure of something here. You know, we all run our own little tests there.
I think there may be brown stars in front of the object as well.
There is. Yeah.
There are 2, 3, 4 of them.
There's countless of them, actually.
5. I keep seeing 6. Oh my goodness.
Oh my
So
God.
that's probably a brown dwarf star with more brown dwarf stars attached to it. And this one is it's emitting quite a lot of light, maybe a more rejuvenated one, because I don't see the a dark core there. But the ones attached to it do have dark cores. As you can see, that they actually steal energy off each other as well.
Prep, did you want me to send you these photographs?
You can do, but I'm testing it now as we're
Okay. You want me to hold? I'll hold the pic.
as we're sitting here, because oh my God.
Yeah.
Hold on. Here, I just fixed it.
Oh, and there's countless on the left and countless on the right. Oh my goodness, they're all over the place. It looks like they're sort of coming from the sun. There are so many within these rays that seem to be coming from the sun. Oh my goodness.
I got Adriana sent me I don't know, two emails showing this object.
Oh my.
This is coming directly from the Azores, so
These objects are just filling up the sky.
And I guess you just have to be in the right place at the right time and capture the photograph. This was on July 28th,
That's
2017
yeah.
at 9:45 a.m.
Hmm.
in the Azores today.
Mate, up there, it's fresh in everyone's minds. Go, zoom in on that image, so everyone's got it in their mind, and then I'll show you what I've got on mine.
There you go.
And this is for the reflection, or the, what do you call it?
The lens flare trolls.
Yeah. Right. So watch this, Scott.
Go ahead. I'm gonna give you
do
the
this.
screen here.
Can you see that?
Yeah.
Look,
Yes.
there's 1, 2, 3, 4, 5, 6, 7.
Oh my.
That's
Oh
no
my
lens flare,
goodness.
guys.
No.
One image. Hang on, I'll get the other one up.
Sure.
That's clear. Is that too blurry?
Wow. It is a little, but it's obvious. These objects on that object are obvious. You can see the dark core. You can see the light ring around it, which is the envelope around the core. It's obvious. It's obvious what they are. These are all brown dwarf stars. Sticking
did you
to
see-
what I would, it's unbelievable.
Do you
Yeah.
see that black one there?
Yes. And it's emitting it.
Does it not look like a pimple?
Yes, it does. Yeah.
That's the same. That object there is exactly the same object
In Neil's
that
video.
I showed you a minute ago.
Wow.
Yeah, we're gonna have to get Neil on
we've
here
seen
with
that.
us.
Yeah, we've seen that image countless times.
Mm-hmm.
And these ones here, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9.
Mm.
Those images were the ones that were superimposed by the sun on Neil's
His video.
video.
Oh my.
So this is, when was this taken?
Today.
Today, 9:45 a.m. in the Azores.
Yeah.
I have about,
So that would have
sent
been-
me probably, I don't know, anywhere maybe 10, 15, 12 photos. I did get a chance to look at a few of them, but then we were getting ready for our live stream, and I told her that I would take a closer look at them because, you know, whenever you start to see cloud covering an object, I mean, how are you going to produce a lens flare or even a camera artifact like that? You know, I'm sure there'll be somebody out there that will take the images, manipulate it, and then try to debunk it. But the fact of the matter is, you know, we have people seeing the same object around the world. It's being photographed and documented, and we just now documented it right here live in front of your eyes from the video from Neil Oakley over in the UK. And I had an email from Neil. We're going to get together, me, him, Prep, and the doctor, and we're going to talk about some of his videos and grab more information from him. But I mean, you can clearly see that, you know, there's something there. We're putting it through some testing right now.
This image was taken roughly, if this was in the Azores, this was taken approximately the same time that Neil was standing in Liverpool in England filming the same thing.
Oh my goodness.
If
Yeah.
you're telling me that this was
because
done yesterday,
Neil's
then
in
that's
the
the
UK.
27th.
Yeah,
So-
I think actually this one is from about 4 hours ago.
9:45 a.m. Azores time.
Yeah.
Yeah, which would be the 27th.
Yeah, actually it's 5 hours ago. I think it's 5 hours ago. No. Oh, Yeah, it's 4 or
So-
5 hours ago. I'm not sure.
Those there are exactly the same planets, objects that were in Neil's video. Exactly the same.
Yeah, they are. Unbelievable.
Well, Prep, we're gonna have to do some work on this. I'm gonna see if I could download Neil's video in a higher definition.
Yep.
And if I'm able to download it in a higher definition, I will forward you the higher definition video. I'll email it to you, and then that way you can work on it yourself. I'm going to work on these images and Neil's video amongst this other CME. I mean, we got our homework set out for us right now. That's that's definitely a fact right there. But the pictures are pretty astounding from the Azores, and Neil Oakley's video, most definitely. Time, all being within, pretty close to the same time. That's pretty crazy.
Yeah.
Mate, Neil Oakley and Seven Spalding, and I've got to give her a dues, a woman called Jada Jody. Out of the three of them, they're the ones that are really filming these things every single day, because they go out there every single day. We're just sitting behind computer screens, but they're the people that are really highlighting these things. And now, like this lady from the Azores who sent you this picture, the reason they've seen these videos, and now everybody's actually going out there and seeing these things. So it's good credit to them. They're the leaders in all this.
Yeah, they're definitely doing some incredible work. And, that's always the best thing, because like I said before, we are all on different corners of this earth. We all have a different perspective. We're all seeing something totally different. And so many people say to me, oh, well, if you're seeing it in New Jersey, how come I'm not seeing it here in Israel? Well, the earth is round. We're spinning, we're rotating, we're moving through space. I mean, that's the best answer I can give you,
Yep.
Just because I see a bird fly through my backyard doesn't mean you're going to see it.
Yeah.
The earth is pretty big, but these are pretty astounding photographs, so I will, I'll start working on some of this today, Prep. You get some rest. We'll touch base later on in your morning, my early evening, if you want to. And we'll see what we come up with, put another live stream together. And hey, ladies and gentlemen, you may see more discoveries live right on this this channel. Make sure you get over to Prep's channel and subscribe to his channel, because he does amazing work, folks. This is what we're looking for. We're looking for the truth. But anyways, I'm going to go ahead and end this live stream so Prep could get some rest. I have a ton of homework to do right here, and the doctor has one more chapter in her book. But anyways, Prep, any last words for everybody before we cut off here?
No, just keep doing what everybody's doing, really. Just go out there and just keep looking at the sky, because, I'm getting pictures. I'll give you an example. There's a woman that sent me a picture, which is less than, I think it's 15 k's from my house. So she's a neighbor, more or less. And she took a picture of the sky from outside her house and sent it to me. And there's a planet in it.
Wow.
Clear as day. So these are becoming more and more prevalent. Like the doctor said, we're just going to get to the point where you can actually stand outside and see them.
Yeah.
So, and apart from that, God bless everybody. Keep doing what you're doing.
Yes, thanks, Prep.
Thanks, Doctor. I'll speak to you soon.
All right there, buddy. You
Okay.
you get some rest, and definitely look for an email from me whenever you get up.
Okay, mate. God bless, eh?
All
God
right. Take
bless.
care. Take care. Well, ladies and gentlemen, we try to bring you as much information as we possibly can. And like I said earlier in our broadcast, you know, I know a lot of these things are going to be hard to swallow, and you're always going to have your disbelievers and the people that want to debunk you. But the fact of the matter is, there are people all around our planet, everywhere, that are making and taking astounding photographs and video and doing research. Maybe they're not as vocal as myself and the doctor and Prep Aussie and some others. But really what we should all be doing is we should all be collaborating and gathering our information and putting it together and trying to bring it to the masses, trying to bring all of it to you. But that just seems to be difficult, a very difficult thing. But as you can see, for all of you that have been hanging out here and watching the information coming in, you know, us showing you what we've put together, and that's just less than a 24-hour period. And while you were here watching, more information came in. Another CME, more earthquakes popping off, floods all around the world, weather changes that are insane. But then you have those people that say, yeah, that's all normal. That's all normal. Okay, well, maybe in your demented world, that is normal.
60
But we
inches
all
of
know it's
rain in
not.
one day in India.
Yeah.
Yeah. Yeah. I mean, where I live right now on the East Coast, we are under a flood watch from yesterday. We have massive storms moving in, dumping 2.5 inches of rain, you know, in a valley area where there are very large rivers, you know, elevations. And I mean, it hasn't even rained yet, 24 hours before they're calling for floods from where I live all the way to the Atlantic coast, New York, New Jersey, Connecticut. So the weather is definitely crazy. Definitely crazy. So everybody, like Prep said, just keep doing what you're all doing. Take your photographs, take your videos. The more eyes that are documenting things, the better off that we'll be trying to figure this all out. We may never figure it all out, but at least we can report on it. That much is a fact. Anyways, Doctor, you did an astounding job today with your observations and your answers. That was fantastic. You actually sparked something in my mind to better describe these objects to our viewers. And
Well,
that was, you know, with the reference to Jupiter.
Okay. Yes. Thank you, Scott. Well, I like to say you were actually doing a marvelous job as a scientist. Don't forget that the real scientists do not want to publish the truth. They are concerned with keeping on doing what they've all been doing up to now and promoting the accepted theories, whilst we are doing the real job of scientists. We're actually discovering the real laws of the universe, doing the real observations that God has provided for us by placing these objects here. And we are talking about the truth and letting people know the truth. And no other scientists have come up to do this job. So basically, it's you and I and Prep doing the observations and coming up with ways to explain them. So
Yeah, you did a great job on that today. And hey, listen, ladies and gentlemen, just keep on plugging away. You know, if you feel you have an opportunity to take a photograph or you want to take some daily photographs, you know, analyze them on your computer. You know, if you're able to cast them onto your big flat screen TVs and get more defined definition, do that. If you need that little technology, go to your local Walmart or go online and order Chromecast. It's a Google product, small little attachment for the back of your TV. You can cast whatever's on your cell phone directly to your flat screen. I love it. It's like having cable TV in your cell phone. But that's another good way to analyze your photographs other than your computer screen. I did it yesterday. I've been doing it for the last year.
Yeah.
These objects are there. We're showing you. But let's get the word out. If any of you want to share this broadcast and our videos on your Facebook page and your Twitter, that would be fantastic. Gets people watching, gets people, up to speed on what is actually occurring. But I'm gonna end this live stream now. I want to get to these photographs that we just captured today. I saw some stuff on the coronagraph, the C2 that I want to get into. I want to check the stereo. I want to check earthquakes. I got to do my job here today. And the doctor is one chapter away from finishing her book. Then we're going to get all of that edited, proofread, and published. And by the way, ladies and gentlemen, the doctor's written several more reports, and I'm going to go ahead and put a video out in a little while about those other reports. If any of you want to purchase those reports, you can do so. You can start using them on your own YouTube channel. And it does help. It does help spreading the word, because you have people that may be subscribed to your personal YouTube channel and they're not viewing us. So you have the opportunity to start utilizing your YouTube channel for a good reason. You're watching us, so you're wanting to do research. You can do it. You can start opening people's eyes. That's what we're mainly here for. Open your eyes, report on what we're finding. Bottom line. And I also want to thank each and every one of you over the course of the last 2 weeks that have stepped up, supported the doctor, supported me, and all of the folks that did purchase her reports. They're doing a fantastic job. I have so many people now that are basically emailing and asking for the future reports. And she's done a bunch of them. Just haven't had the time to get them up to you guys. We're also going to be touching base here very, very soon on this eclipse. The doctor's written a full report on this eclipse. I think it's going to be a big deal. There are some that are saying that this may not actually be an eclipse like what we're thinking. And maybe there's more to it. But we're going to find out. We're definitely going to find out. And the doctor will be doing a report on this eclipse. So stay tuned. Be looking for it. I'm going to go ahead and sign off now, folks. Thank you very much for watching. This is the Rogue Physicist and Scott from the Nibiru channel. Thanking you for watching. Take care, guys.